All right, here's another what if scenario. What if the angle in question, what if theta is negative, or it's a multiple revolution angle? What if we do is more than 360? What if we have a 545 degree angle? Or what if we have a 630 degree angle? What if it's beyond one revolution? Or what if it's negative? What if we have a negative 120 degree angle? How do you handle that? All right. Well, here's the key reference. Coterminal angles. What does that mean? Coterminal angles. So if this is 30 degrees, then there are a wide choice of angles that are coterminal. For example, we could do one angle that's coterminal with 30 is, so if this is theta, call this theta number 1. Then theta number 2, that's coterminal, this is negative 330 degrees. Those are coterminal angles because they have the same terminal side. Or, if you don't like, or if the circumstance of the problem you need to be addressing, if the circumstances of your problem require it, rather than mark it as a negative angle, one thing you could do is you could go multiple revolutions. And so another possibility is you add 360 to 30, you get 390 degrees. You have 390 degrees. Those are all coterminal. And we could have many, you could take 30 minus 360, it's negative 330. Subtract another 360, subtract another 360. Or add another 360, add another 360. You can add or subtract as many revolutions as you like, generating each time another coterminal angle. It doesn't matter how many times you do it. It doesn't matter which coterminal angle you find. This is why being able to know, if you were given a 400 degree angle, you need to be able to find the one revolution angle which is coterminal with it. If you're given 400 degrees, you need to be able to find the one revolution angle which is coterminal with it. And here's why. Coterminal angles have equal function values. Coterminal angles have equal function values. Here's why. Now, there's nothing magic about 30 or 390 or negative 330. This can be any angle. Here's why this is true. You don't need to write this. I'm just demonstrating, sort of illustrating why this statement is true. Suppose this is angle theta. Well, pick any one of the functions. Just pick one at random. Let's just pick a tangent. It works with any one of the 6, so I'm just going to pick tangent at random. We know tangent of theta is y over x. Let's do another one just to be sure. Let's do cosine. Cosine of theta. Cosine of theta is x over r. We could pick any one of the other 4. The same argument would hold. So this is theta. What that means is if I choose any point on this terminal side, call it x comma y. I can choose any point on this terminal side I want. From that value x, that value y, you drop the perpendicular, you determine the value of r. This is now x, this is now y, and we're off to the races finding our values. But look, suppose I go one complete revolution and then theta degrees. So my theta is in here. So this is now theta plus 360. So the question is, what now? If I call this, let's call this theta 2. Call this one theta 1. So this is theta 1, this is theta 2. Theta 2 is the coterminal angle to theta number 1. But look, the point, since they have the same terminal side, that means this point, x comma y, which lies on the terminal side of theta 1, also lies on the terminal side of theta 2. And so this exact same y, x, and r can be used to find the function values for tangent or cosine or any of the other function values for theta 2. And so tangent of theta 2 is also y over x. Y over x is also tangent of theta 2. Well, eliminate the middleman. Tangent theta 1 is equal to tangent theta 2. Look at cosine for theta 2. It's the same x, it's the same y, it's the same r. Therefore, cosine is adjacent over hypotenuse, that's x over r. So this is also equal to cosine of theta 2. Well, eliminate the middleman, and those are equal to each other. And that's true of all the other function values. That's true of any coterminal angles. So if you want to find the function value of an angle, which is greater than 1 revolution or which has gone negative, however many revolutions you want to go, first find the single revolution value, which is coterminal to it. The function values of the single revolution are equal to the function values of any coterminal angle.